Right now, Christina Koch is racing toward the moon at thousands of miles per hour. She is a world-class engineer and a record-breaking astronaut, but she is also operating in a vacuum that was, for 50 years, engineered for someone else. Space is already trying to kill you, but for female astronauts, the danger often starts inside the hardware. We aren't just talking about representation. We are talking about life or death physics. For decades, life support and pressure suits were tuned for a single body type, the 50th percentile male. Today, we are finally redesigning space gear to fit the human form, and the stakes are a matter of survival. In the 20th century, aerospace engineering had a default human, a 175-pound male pilot. Every seat, every reach zone, and every oxygen scrubber was tuned to his metabolic rate. This wasn't just a lack of diversity. The gear literally didn't work for them. Remember the 2019 all-female spacewalk delay? It wasn't because the astronauts weren't ready. It was because the suits weren't. When a suit is too large in the shoulders, the pivot of the arms shifts, causing high-velocity bruising and suit trauma. In the vacuum of space, an ill-fitting suit isn't just uncomfortable. It's a mechanical failure of your personal spacecraft. To fix this, NASA and Axiom Space moved to the Axiom Extravehicular Mobility Unit, and XCMU, Exploration Extravehicular Mobility Unit designs. This isn't just about small sizes, it's about re-engineering joint-bearing placements. Women generally have narrower shoulders and different hip pivots. The new lunar suits utilize modular joint designs that allow for a range of motion that Apollo-era astronauts couldn't dream of. We are moving from one-size-fits-most to precision-engineered mobility. This ensures that when Christina Koch, or the next woman on the moon, reaches for a geological sample, she isn't fighting the internal pressure of her own suit just to move her arm. But the real battle is internal. Female physiology is more sensitive to cosmic radiation, particularly in tissue types unique to the female form. For years, this led to lower career exposure limits for women. But in 2026, the data has shifted. NASA has moved to a universal 600 millisieverts limit, but achieving that requires individualized radiation shielding. We're also looking at the IL-6 protein, the main reason behind microgravity bone density loss. Because women's bone mineral density can degrade at different rates, those workout machines on Artemis aren't just for staying fit. They're medical tools designed to keep an astronaut's bones from thinning out in zero gravity. As we look toward the Gateway Station and eventually Mars, designing for everyone isn't a nice-to-have anymore. It's a non-negotiable safety requirement if we want the mission to succeed. From carbon dioxide scrubbers recalibrated for different metabolic rates, to modular ergonomic controls that anyone can reach in an emergency, we are building a better system for all of humanity. When we solve these problems for women, we end up making space safer for every astronaut, regardless of their build. We are finally moving beyond optics and into the era of precision engineering. The blueprint for the stars is being rewritten right now, 200,000 miles away. If you think engineering should dictate the mission, and not the other way around, hit that subscribe button. What's the next engineering gap we should bridge? Let me know in the comments. This is NASA Community News. We are built for the next giant leap.